to add a surge protector to a 600 amp main disconnect, firstly, prioritize safety. Turn off the power to the main disconnect and implement a lockout/tagout procedure. Always wear appropriate personal protective equipment, including gloves and safety glasses. Secondly, determine the voltage rating. The surge protector must have a voltage rating equal to or greater than the maximum voltage of the main disconnect, which is 480V/277 volts. Thirdly, calculate the required surge capacity. This involves determining the potential surge current based on the application and location. Consulting with a qualified electrician is recommended for assistance in this calculation. Select a surge protector with a surge capacity that exceeds the calculated surge current. Fourthly, focus on selection and placement. Choose a surge protector specifically designed for industrial applications and high-voltage systems. Locate the surge protector as close as possible to the main disconnect. This minimizes the distance surge current travels, protecting sensitive equipment. Fifthly, consider the wiring configuration. Connect the surge protector to the main disconnect as follows. On the line side, connect the input terminals labeled Line 1, Line 2, and Line 3 of the surge protector to the corresponding output terminals of the main disconnect. On the load side, connect the output terminals labeled Load 1, Load 2, and Load 3 of the surge protector to the input terminals of the equipment or the downstream distribution system. Sixthly, ensure proper grounding. Connect the grounding terminal of the surge protector to the grounding system of the motor control center. Seventhly, perform inspection and testing. After completing the installation, visually inspect the surge protector for any damage or loose connections. Perform a surge protection test to verify proper operation. Additional considerations include MOV, which is metal oxide varistor technology. Most industrial surge protectors utilize MOV technology to dissipate surge energy. Also, consider fail-safe operation. Select a surge protector with a fail-safe feature that opens the circuit in case of internal failure, preventing further damage. Some surge protectors feature indicator lights that provide a quick visual indication of the protection status. For complex or high-risk installations, consulting with a qualified electrician is highly recommended to ensure proper selection and installation of the surge protector. Surge protectors play a crucial role in safeguarding electrical equipment from transient voltage surges, also known as spikes or overvoltages. These surges can originate from various sources, including lightning strikes, utility switching, and the operation of heavy electrical equipment within a facility. Without adequate surge protection, these transient voltages can damage or destroy sensitive electronic components, leading to equipment failure, downtime, and costly repairs. The selection of an appropriate surge protector involves several key considerations. Firstly, the voltage rating of the surge protector must be compatible with the voltage of the electrical system it is intended to protect. For a 480V/277 volt system, the surge protector must have a voltage rating of 480V/277 volts or higher. Secondly, the surge current capacity of the surge protector must be sufficient to handle the expected surge currents in the application. This is typically determined by considering the location of the equipment, the likelihood of lightning strikes, and the presence of other surge-generating equipment. Thirdly, the surge protector should be designed for the specific application and environment in which it will be used. Industrial surge protectors are typically more robust and offer higher surge current capacity than surge protectors designed for residential or commercial applications. The installation of a surge protector should be performed by a qualified electrician in accordance with all applicable electrical codes and safety regulations. The surge protector should be installed as close as possible to the equipment it is intended to protect, and it should be properly grounded to provide a low impedance path for surge currents to flow to ground. The wiring connections should be tight and secure to ensure reliable performance. After installation, the surge protector should be tested to verify that it is functioning properly. This can be done using a surge tester, which applies a simulated surge voltage to the surge protector and measures its response. The test should confirm that the surge protector is clamping the surge voltage to an acceptable level and that it is not damaged by the surge. In addition to the initial installation and testing, surge protectors should be periodically inspected and tested to ensure that they continue to function properly. The frequency of these inspections will depend on the application and the environment, but it is generally recommended to inspect surge protectors at least annually. Surge protectors are an essential component of a comprehensive electrical protection system. By properly selecting, installing, and maintaining surge protectors, you can significantly reduce the risk of damage to your electrical equipment from transient voltage surges. Metal oxide foresters, or MOFs, are a common component used in surge protectors. These are semiconductor devices that exhibit a variable resistance depending on the voltage applied across them. At normal operating voltages, an MOV has a very high resistance, effectively blocking current flow. However, when a transient voltage surge occurs, the MOV resistance rapidly decreases, allowing the surge current to flow through it and divert it away from the protected equipment. The MOV absorbs the energy of the surge, clamping the voltage to a safe level. Over time, MOV can degrade due to repeated exposure to surge currents. This degradation can lead to a reduction in their surge handling capacity and eventually to failure. For this reason, it is important to select surge protectors with adequate surge current capacity and to periodically inspect and test them to ensure that they are still functioning properly. Some surge protectors include indicator lights or other status indicators that provide a visual indication of the MOV condition. These indicators can help to identify surge protectors that need to be replaced. A fail-safe mechanism is designed to protect the electrical system in the event of a surge protector failure. This mechanism typically consists of a thermal fuse or a circuit breaker that will disconnect the surge protector from the circuit if it overheats or experiences a catastrophic failure. This prevents the surge protector from becoming a fire hazard or from causing further damage to the protected equipment. The National Electrical Code, or NEC, provides requirements for the installation of surge protective devices. These requirements cover topics such as the location of surge protectors, the wiring methods used to connect them, and the grounding requirements. It is important to comply with all applicable NEC requirements when installing surge protectors to ensure a safe and effective installation. Article 285 covers surge protective devices, or SPDs. Type 1 SPD are permanently connected and intended for installation between the service equipment and the load. Type 2 SPD are also permanently connected but are intended for installation on the load side of the service equipment. Type 3 SPD are typically cord and plug connected and are intended for use at individual pieces of equipment. The NEC also specifies the minimum surge current rating for surge protective devices. This rating is based on the size of the service and the type of equipment being protected. The NEC also requires that surge protective devices be listed and labeled by a recognized testing laboratory. This listing ensures that the surge protector meets certain safety and performance standards. Grounding is critical for the effective operation of a surge protector. The surge protector must be properly grounded to provide a low impedance path for surge currents to flow to ground. This grounding path should be as short and direct as possible to minimize the voltage drop across the grounding conductor. The NEC specifies the requirements for grounding surge protective devices. These requirements include the use of appropriately sized grounding conductors and the proper connection of the grounding conductor to the building's grounding electrode system. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. In addition to the grounding conductor, the surge protector should also be bonded to the equipment grounding conductor. This bonding helps to equalize the voltage between the surge protector and the protected equipment, reducing the risk of damage from surge currents. Surge protection is an important aspect of electrical safety. By properly selecting, installing, and maintaining surge protectors, you can significantly reduce the risk of damage to your electrical equipment from transient voltage surges. Always consult with a qualified electrician to ensure that the surge protection system is properly designed and installed. Surge protectors are rated by the clamping voltage, which is the maximum voltage that the surge protector will allow to pass through to the protected equipment. The lower the clamping voltage, the better the protection. However, a low clamping voltage also means that the surge protector may be more susceptible to nuisance tripping. Surge protectors are also rated by their energy absorption capacity, which is the amount of energy that the surge protector can absorb before it fails. The higher the energy absorption capacity, the better the protection. Surge protectors are available in a variety of configurations, including panel mount, DIN rail mount, and plug-in. The type of surge protector that is best suited for a particular application will depend on the specific requirements of the application. Surge protectors are typically installed in parallel with the protected equipment. This means that the surge protector is connected between the line and neutral conductors, or between the line and ground conductors. When a surge occurs, the surge protector diverts the surge current away from the protected equipment and to ground. The surge protector operates by clamping the voltage to a safe level. This clamping action prevents the voltage from rising to a level that could damage the protected equipment. Surge protectors are an important part of a comprehensive electrical protection system. By properly selecting, installing, and maintaining surge protectors, you can significantly reduce the risk of damage to your electrical equipment from transient voltage surges. Remember to consult with a qualified electrician to ensure that the surge protection system is properly designed and installed. When selecting a surge protector, it is important to consider the type of equipment that will be protected. Some equipment is more sensitive to voltage surges than others. For example, electronic equipment such as computers and televisions are more sensitive to voltage surges than appliances such as refrigerators and washing machines. It is also important to consider the location of the equipment. Equipment that is located near the service entrance is more likely to be exposed to voltage surges than equipment that is located further away. The NEC provides guidelines for the selection and installation of surge protective devices. These guidelines should be followed to ensure that the surge protection system is properly designed and installed. A surge is a transient voltage that can reach thousands of volts and last for only a few microseconds. These surges can be caused by lightning strikes, utility switching, or the operation of heavy electrical equipment. Surges can damage or destroy sensitive electronic equipment. Surge protectors are designed to protect equipment from these surges. Surge protectors work by diverting the surge current away from the protected equipment and to ground. This protects the equipment from the damaging effects of the surge. Surge protection is an important aspect of electrical safety. By properly selecting, installing, and maintaining surge protectors, you can significantly reduce the risk of damage to your electrical equipment from transient voltage surges. Consider consulting with a qualified electrician to ensure that the surge protection system is properly designed and installed. Proper wire gauge is important to consider when installing a surge protector. Refer to NEC Table 310.16 for ampacities of insulated conductors. The table lists the allowable ampacities of insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius, not more than 3 current-carrying conductors in a raceway or cable or earth, based on ambient air temperature of 30 degrees Celsius. A 600 amp disconnect will likely require large conductors, and the surge protector conductors need to be similarly sized or are specified by the surge protector manufacturer. Coordination with the existing electrical system is important. The surge protector should be compatible with the existing electrical system and should not interfere with the operation of other equipment. The surge protector should be installed in a location that is accessible for maintenance and testing.